All right, let's get right into it. If you look out into the constellation Perseus, somewhere between 2,500 and 3,500 light-years away, you'll find one of the faintest, but also one of the most intriguing objects on the famous Messier list. This is Messier 76, and it looks exactly like a celestial ghost. But this isn't just a pretty picture. This is a ghost with a story, a really wild story of a violent death and a bizarre rebirth.
I mean, just look at this thing. It's so easy to see how it got all its nicknames. That bright part in the middle looks just like a tiny dumbbell. The wings give it that butterfly shape and, my personal favorite, the dog bone. You can totally see it if you kind of squint, right? It's what astronomers call a bipolar planetary nebula, and it is just absolutely gorgeous.
But you really shouldn't let that delicate look fool you, because when astronomers started digging into what's actually going on inside this nebula, the story just gets weird. The normal rulebook for how these things are supposed to form, Messier 76 just throws it right out the window. So what in the world is going on here?
Okay, so to solve this mystery, we first have to understand how a bipolar nebula is supposed to work. There's a pretty standard recipe that astronomers have figured out. It's all about how two different winds of gas coming from the star interact with each other to carve out the shape that we see.
So, here's the key. It's a two-step process. First, you have an old dying star that puffs off its outer layers in this really slow, gentle wind. This creates a dense, donut-shaped ring of material right around its middle. Think of it like a cosmic belt. Then, the star's super hot core gets exposed, and it unleashes a second wind. But this one is way, way faster. This new wind slams into that donut, and the donut funnels the blast out the top and the bottom, creating that classic two-lobed shape we see. Pretty straightforward, right?
Well, here's where our ghost story takes a very sharp turn. See the star at the very heart of Messier 76? It doesn't follow the rules at all. It's the prime suspect in this whole cosmic mystery, and its profile is anything but standard. This is where the whole standard model just completely falls apart. For starters, the central star is missing that thin layer of hydrogen it's supposed to have. Instead, its surface is packed with helium and, even weirder, a massive amount of carbon. And it is scorchingly, unbelievably hot. We're not talking about a small difference here. This is a totally different kind of star than what we should be seeing.
And when I say hot, I mean really hot. We're talking a surface temperature of around 208,000 Kelvin. Now we know this because we can study how its intense light energizes all the gas floating around it. And the result of those calculations? It's more than 35 times hotter than our own sun. That is a massive clue that something incredibly dramatic went down here.
This temperature and its weird composition put this star in a super exclusive club. In our entire galaxy, the Milky Way, we only know of about 40 stars like this one. So the fact that we found one right in the center of this nebula tells us we're not just looking at a normal star's end-of-life story. We're looking at a real, genuine freak of nature.
So how does a star even get this strange? How does it completely rewrite its own ending? Well, the answer is in one of the most violent events a dying star can possibly go through. A final, explosive gasp that literally brings it back from the dead.
I just love this quote from one of the astronomers who studied it. It perfectly captures this bizarre do-over the star pulled off. It was on the normal path, fading away quietly into a white dwarf, but then at the last second, it basically decided, I'm going to do that again, and reignite it in this massive cataclysmic flash.
And this is the solution to the whole mystery. It's called a late helium flash. So just as the star was cooling off, the shell of helium right under its surface got so hot and so dense that it just ignited, a runaway thermonuclear explosion. This event blasted away any hydrogen that was left, it dredged up tons of newly made carbon to the surface, and it sent the star's temperature through the roof. For all intents and purposes, the star was born again.
Now, this born-again moment wasn't just some quick flash of drama. It completely changed the star and the nebula around it forever. And it left behind a whole series of cosmic fingerprints that we can still see today. So let's look at the evidence this cosmic rebirth left for us.
This is a perfect example of how we piece this story together. On the right, that's what we see in visible light. You're looking at the hot gas being lit up by that incredibly hot central star. But now, look at the image on the left. This is the same object, but seen in far infrared light, and it tells a totally different story. Here, we're seeing the glow from cool dust and complex molecules. This is the chemical fallout from that violent helium flash. And the evidence is just all there, it's undeniable. The nebula is loaded with carbon, more than twice as much carbon as oxygen, which is a direct signature of that helium burning into carbon. The whole structure is super clumpy, with these weird knots of molecular hydrogen that somehow survived that blast. We also see big old dust grains left over from its first death, mixed in with all the new stuff. And to top it all off, the entire nebula is creating a bow shock as it smashes through interstellar space. Every single one of these strange features is a direct consequence of that one violent, born-again event.
So when you put it all together, that's what Messier 76 really is. It's not just another pretty space picture. It's the incredibly rare evidence of a star that died, came back to life in a flash, and then started the whole dying process all over again. A true freak of nature.
This amazing object is just such a powerful reminder that the universe is packed with exceptions to the rules, and that sometimes a star's final moments can be its most spectacular. It really makes you wonder, doesn't it? As we look out at the sky, what other incredible stories of cosmic life, death, and rebirth are just hiding out there, waiting for us to figure them out?